I guess we'll start. Hopefully we'll get some more people joining. We are at the very end of the of this very, very big conference center. So good afternoon to everyone. I'm Régis Decorme from R2M Solutions, and welcome to this last workshop of day one of Sustainable Places. So this one is on advanced manufacturing of new generation renewable plants. So you see we have 5 EU projects which were scheduled for today. We have one dropout engine. In fact, we had a slight misunderstanding, so the speaker is in fact not there with us. So the session will be a bit shorter. We have then 4 projects, and in fact the 4 projects are all focused, I believe, on photovoltaics. So well, the discussion should be quite interesting. And again, all of them are very much focused on new ways of manufacturing PV with zero defects and many different techniques that we will explore today. So we will have with us 4 speakers. We will start with Super Tandem, presented by Martina Chopard from Amires. Then we will have Flex to Energy, presented by Rodica Souteu, who is from the Build and Connect French cluster. Then we will have Philippe Tony from CEA. He's going to present the Seamless PV project. And finally, we'll have Victor Izquierdo from IREC, who will introduce the Platform Zero project. So we will keep the presentations quite short. And then the idea is to have something like 20 minutes, maybe a bit more, since we have a bit more time, for discussion between our projects. And perhaps we identify some possible synergies for after this session. Voilà, so I suggest we start, and again we start with Super Tandem, and I will put the slides.
So, hello everyone. I think we will have like a little session just between the projects. Unfortunately, this room is quite hard to find, so maybe all the conference participants couldn't reach it.
I'm not in the projects.
Wow, so I hope you have many questions for all of us. Perfect. So I'm here to present Super Tandem. It's maybe a bit different to all the other projects that are included in this session, because we are not focusing purely on the manufacturing optimization. Actually, this project is focused on selecting and optimizing materials and manufacturing processes to develop highly efficient, so over 30% of efficiencies of all perovskite tandem photovoltaic modules on flexible substrates. So it's a research and innovation action, so bear it in mind. We are aiming to really focus on the industrial scale-up, etc., but still you will see with the pictures that I show you that we are not there yet, especially with the manufacturing, but we are getting close to some of the targets that we imagined. So I will show you now one of the modules that we already developed. So it's a flexible module, 10 by 10 centimeters. So still, we are not printing the newspaper like we imagined, but hopefully we are getting close. So the objectives of the project are mainly first focused on the development, on the material side, and on the manufacturing side, like I already mentioned. So first we were trying to, now we're halfway through the project, to optimize and fine-tune the single junction cells. So fine-tune the materials to reach as high efficiency as possible, and focus on materials that are earth abundant. So trying to eliminate the ones that are expensive and also that are rare. So once we have these cells, these single junction cells, maybe I will use the pointer. We want to stack them on top of each other. So combine the wide band gap and the narrow band gap and all the other necessary layers, like the recombination layer and all of that, in 2 tandem cells, which we hope by the end of the project will have efficiency over 32%. This is quite ambitious. You will see that currently, for example, the silicon-based flexible modules have efficiencies around 10 to 12%. So this is a big jump. Obviously, this is based on the performance of the perovskites. So we are trying to balance the advantages of perovskite being really lightweight and possible to use on flexible substrates, but we need to balance it with its really instability for now on larger scale. We also want to reduce material costs, like I said, and we want to work on the scalable manufacturing processes. So we are already even at this lower stage. We are already thinking how these all perovskite modules can be produced on the industrial scale. So we want safe and low-cost processes. We want to already monitor the CO2 footprint of these processing technologies. And we want to include or focus on all the aspects, so the coating, the patterning, the interconnection, etc. We are also trying to think about already the sustainable packaging. After in the discussions, we can maybe look at what are some of the hotspots or some of the issues we identify so far in terms of the materials, in terms of the packaging, in terms of, let's say, the processes, what are the environmental hotspots that we have until now. And currently, we are trying to demonstrate these modules 10 by 10 that you have already seen, and we want to deliver a proof of concept for large area manufacturing. So we have also some long-term objectives. We want to reduce the production costs. So again, since the beginning, and we reiterate it every 6 months, we try to see where to optimize the cost versus the environmental impact, and we want to reach the efficiency that I mentioned, but stay below 20 euros at meter square on industrial scale. Again, this is a vision for the long term. It will not be achieved by the end of the project, but hopefully in some follow-up, you will also see later on. We want to also work on the recycling routes. Main issue with the perovskite materials is that they use, or basically, sometimes or most often, we employ some problematic heavy metals. Mainly it's lead that is used in these perovskite materials. So we need to be sure that we minimize the waste and we ensure that these devices can be recycled, and there is a full strategy for the end of life. One important result that we already have is one of the partners already patented the recycling strategy for the cell level. So this happened 6 months ago. They have a solvent that works 99% recovery of the lead. So this was a huge achievement in the project. We can discuss maybe later on. And then, of course, long-term, we also want to focus on the stability, because, as I mentioned, this is one of the issues that perovskite-based, or all perovskite tandem devices have issues with. They are really sensitive to all the outdoor elements. So we want to also focus on the stability. And we want to, at the end of the project, come up with a blueprint how these smaller, let's say, devices that we develop now could be produced on a future roll-to-roll a production line. So where we are right now and what are the project partners. So you can see here the modules that we are currently testing are very much still small. It's very far away from the roll-to-roll production. So they are really tiny compared to all the partners. This is taken at Tecnalia in Spain, where the outdoor testing was done, the first campaign. So now we reach some good levels of efficiencies. We reached 26% for the all perovskite devices on rigid substrate and 25.4% on flexible substrate. So these are good results. Now in the second half of the project, we are trying to focus on upscaling and on testing the stability in further campaigns. And when we come to the manufacturing technologies and what is next for Super Tandem, this project is supposed to finish in 2025, and we want to deliver a blueprint, like I already mentioned, of this roll-to-roll inline production facility of all perovskite tandem modules. This will be done in cooperation with the partners that I will mention later on. Here I forgot to mention, but I will tell you who is involved. So these industrial partners that we have will combine the tools they already commercially offered and create this blueprint. So we have 3D Micromag, who is developing the roll-to-roll laser scribbling tools. So they want to optimize them and launch them for flexible perovskite solar cells in 2026. We have SAD in Eindhoven, who is developing the atomic layer deposition equipment. And again, they are optimizing the equipment and the recipes for new thin films. They also want to release this in 2026. Then we have Saule in Poland that are actually already investing in this pilot scale manufacturing plant that will also have the possibility to produce two-junction perovskite modules. They primarily want to focus on the market of BIPVs and indoor light harvesting. And like I already mentioned, they also developed the recycling process. This is the partner that invented that patented the recycling process. So they want to launch this pilot plant in 2027. And of course, we also have the slot die coating machines that will be introduced by Foam Technologies, optimized for the inline production of tandem cells. And they expect to have this in 2028. So I hope you're excited for the results and outcomes of Super Tandem. Of course, for further collaboration, if you want to come up with some follow-up projects, some innovation action after the end of the project, we're open for collaboration. So thank you for this, and in case this is my contact details.
We have already some questions.
What is the lifetime that you are currently expecting for this cells?
Maybe currently the lifetime is it's hard to predict, because if you see, we have only completed 1,000 hours of outdoor testing. So it's quite hard to predict. Now we have concluded the second campaign, so maybe we will have more estimations afterwards, but it's really still too early to to give answers, I guess.
Thank you. Any other question?
About the stability, this is glass-to-glass encapsulation, or is?
I think so.
It's glass-to-glass encapsulation. Okay, and which is the material for the narrow material? Because you present a narrow and white cap.
I could give you an example afterwards. So we have different stack options. Currently, partners are testing different materials. So in the beginning, we selected some that we thought would be optimal in terms of cost, sustainability. Now, half term, we are running into the issues that the sustainable ones are not really cheap and are not performing as well as the non-sustainable. So, like, for example, we thought to eliminate fluorine, but this is proving to be almost impossible. We tried to reduce indium content, also so far it's proving impossible, but afterwards I can show you some stacks that we were working with. I'm not sure what these ones are, but I can look it up afterwards.
Okay, thank you.
Okay.
So we'll move to the second project, and that's going to be Flex to Energy, presented by Rodica from Build and Connect.
Hello, everybody. We have our project is Flex to Energy. It's now in its second year, and we are working on flexible solar panels, which with a different method than what was presented previously. These are the general information, is the general information of the project. It's an innovation action. It's a project which will last for 4 years with a total budget of 20 million and European contribution of 15 million. We intend to develop a product which could be manufactured for 1 million square meters per year. So this is a big challenge in innovation, because we have to have a very competitive product, and we have to develop a market. So that's quite difficult. But the main problem with this kind of solar panels is they are very expensive and they don't have a very long life, and they are not as efficient as the solar panels which are on market today. We have 15 partners in our consortium, and now I think we are even 17, because Mondragon, the fourth partner, yes, in fact, we have more countries than previously, because they opened subsidiaries in Spain and France. They were initially in Germany. This is our work plan. Of course, it's we started with studying the requirements and the specification for the design of. I'm not sure I could tell you what PPL is, but it's the company which prints these solar panels. Then we are today in the phase of printing samples and testing them. It is important to have also very robust metrology technique. So we have a partner which is specialized in metrology. It should be a product, a type of assembly equipment which is easily adaptable. Then we studied the integration of the equipment and technology in process of manufacturing. We are working on the efficiency and the cost of the products. And finally, we will test these products on 3 different cases. And we are working on the market strategy and social adoption. And I think this might be a point where we could collaborate and reunite our forces, because it's a lot of work to do, and we have to have an influence towards the public authorities who decide, who give regulation, helping this kind of products to come on market, according financing for using them. So I hope we will meet again. Our main partner is OET in Thessaloniki, and they are already producing OPVs, but now they are working on this improved concept. So they will have the coating stations, drying steps. It's all the automated assembly machine. This was already, it's a project already done with all these steps in the production: coating, drying, laser processing, automated assembly, robotic handling, real-time integrated quality control, high accuracy monitoring, artificial intelligence platform, and digital processing. There are several types of panels. So there are rolls, just with the flexible sheet. Then it can be encapsulated with polycarbonate sheets, with glass sheets, and of course the electrical system comes with afterwards. So the final products are or the glass, and there are 2 types of using the glass. The polycarbonate for in agriculture use, or park or carports, and then the flexible sheet which can be applied on several products, even cars. Our demonstrators are for the building, so we choose the two buildings. It's Alba Iulia Town Hall and Alumil, our partner which will produce the windows. They will test the use of these panels in Alba Iulia. They have a curtain wall which makes it quite difficult to demontate the windows and change the glass and put it again. So we'll just apply the flexible PV on the glass as it is. In Alumil, they will produce the windows and we'll test the windows. For the green houses, we have already built greenhouse. So next year we will install at the beginning of the year we will install the PVs and we'll survey the production, the agricultural production, because it will be less sunny. Sometimes it's good because there are things like tomatoes, they are very sensible to high heat. So it's better to have a little shadowy environment. But we just want to test the productivity and find how it works. We will test these panels on carports and on Fiat Ducato, and I think we will have a second car model on the rooftop and on the sides where there are no windows. These panels, these PVs can be installed. So you have here it's shown how the OPV is integrated into the glass, and then the prototype manufactured. There is actually, we have a transparency of 60%, so it's a bit better than the previous OPVs. But we would like to obtain more. One great quality of these OPVs is that they are sensible on the two sides, so they get solar light and they get the reflected light from the interior. They have better efficiency. So as I told you, the greenhouse it's already built. We will soon install the OPVs, and we will test on Fiat Ducato the efficiency of these OPVs. They are very resistant in extreme temperature. It's a large gap. I'm not sure I'm using the right word. It's like minus 20 and plus 90. It's a large temperature lab. So we have you could see us on LinkedIn, Facebook. We have a Flex to Energy site for social media, and we didn't my colleagues didn't present in these slides our idea of we want to form an international cluster for the renewable energy, but specially orientated to solar energy and new PV's researches, because I think we should permit to more people to know about our researches. We spoke with researchers in France who tested this kind of solution. It was a company who had to stop its production because they didn't have a very good market. Happily, their printing system was available or could be used for another product, so it wasn't lost. But they had a very big capacity and they didn't have clients, and the product was good enough, but it was hard to get on a market with such a new product. So I think we should unite our forces to influence the administrations and also to disseminate the news about this. And that's all for me. So if you have any questions.
Thank you. I have some question about you speaking in the beginning that there are problems about the cost, the ratio between cost and the stability, no? What is the state now? What is the stability of these products and what is the cost approximately?
I don't know much about the technical issues, and they are still developing it. So we cannot give you a very precise data. It changes with time. We are still researching. The costs are still elevated, so a fixed solar panel will always be cheaper. But we know it's a very aggressive market strategy from China. Yeah. So it isn't the real price, it's just the government subventions. But we are really approaching a cost which is reasonable, because it was very, very high some years ago. And that's, we hope we'll find a good balance between cost and efficiency and time and I don't know, and the lifetime of PVs. Okay. But we'll let you know as soon as we have as we know more about it.
Okay, thank you.
Yes, so I am coming a little bit out of the field, but I see sort of a perfect match with this vehicle integrated PV, because if it has a relatively short lifetime, so does the vehicles. So I think it would be a better match than building integrated, because buildings have a very long lifetime. So the vehicle integrated, and I think the agri-PV is also very good because they are easier to install in a new room.
Yes, that's true.
Not a question, but a comment.
Thank you.
One last, if I may, you mentioned Armor, so they were partner in your project, or?
No, they were not partners, but we did contact them because we wanted to form this international cluster, and we knew they had an experience, and maybe they would like to know what's happening, and if they can try again. We couldn't speak to someone from Armor because they didn't respond to us, but we spoke to the researcher of CEA.
In the room.
And he was a bit disappointed. He said, it's impossible, it's so expensive, so inefficient, it cannot come on the market. But things do have an evolution. So we would be happy to speak with you and to...
They phased out the production of OPVs, so that's why I guess they're not interested in that.
Yes.
Yes, they stopped. Indeed, my company, Artwem, we are also active commercially in this sector of BIPV. We are reseller of Onyx Solar, which in fact is manufactures PV glass. And on my side, I'm focused on the French market only. And I can only confirm that it's a very difficult product to sell. But on my side, not so much on the cost. The main problem that I face is the regulation. It's French regulation,
Yes.
which is
Yes, it's
impossible. And I don't think what I'm trying to sell is something as innovative as you are presenting today. It's just, crystalline silicon in PV glass, and that's it. But for French regulation, it's still seen as something so innovative that it has to go through many steps.
Yes.
So it's a very long process of certification to get the approval, to put this into a building, to get it insured. So at the end of the day, the clients, they are just like, okay, I don't have time to waste on that, so I will do simple glass instead. So I don't know if that's specific for France, but...
I think a bit, yes.
A bit.
It's a bit more
I can say that
difficult.
No.
We have this problem in access project for Finland.
Okay,
For
so
PV
it should...
facade.
yes, as well.
Yeah.
So it's could be a topic discussion.
Yeah, maybe I have also a question or for discussion among everyone. We were also trying to submit a proposal focusing on OPVs for IoT applications, so like also flexible substrates. And the main, so it didn't get funded. And the main argument is that this is not innovative enough. That OPVs are basically, like a dead technology. Also, Armor is stepping out of this. Other big players are trying to find the next new thing. And maybe I'm biased because I work with perovskites, but what do you think, all of you, about this? Do you think OPVs? But your project was funded 2023, so I guess they found it innovative. So I don't know.
Yes, I think that they find it's worth researching.
Maybe it's also focusing on the manufacturing line more than the OPVs themselves, because maybe it could be adapted for other.
You are for the perovskites, you are right, because it's still a wet-based process mainly. So it can be seen as a new generation that will replace the OPV, as the manufacturing process are quite similar.
Yeah. So hopefully maybe we can have this at some point, but let's see.
I know that at ETT we have research on OPVs and perovskite also.
Okay.
But usually it's like conflicting groups in Fraunhofer, ISC, they also have OPVs and perovskites.
All right, so we move to you, Philippe. Thank you very much again.
Okay, so good afternoon. So I'm working in CA, Philippe Tony, and I will present the Seamless PV project that was funded in the same call as you, so D30103. But in this project, we are focusing on silicon technology. This is, it's managed by Technalia. The coordinator is Technalia. So these are the objectives of the project. So we have several steps. So the first one is to build pilot lines that can provide advanced and flexible manufacturing with a 2.0 industry level of automation. And the goal is to reach also high efficiency for crystalline silicon PV cells. We bring also new manufacturing processes, not only the basic process of stringing, lamination, and so on. We try to have some innovation in these manufacturing lines. The goal is to get somehow some new modules with lightweight capability and high level of integrability in various applications, as you mentioned, agriPV, VIPV, BIPV, and so on. The goal is not to have a field PV. We are looking for cost reductions, of course, and we are looking for seamless integration in this final application I just mentioned. And we have also demonstration and products. So we are looking for efficiency, cost competitiveness, and compliance with market requirements. And this is an important point. We will see that, and we have this question already discussed. And we have several efforts in this area of standardization, in fact. And you see the partners of this project. We still have Mondragon. This is the Spain. And I think the French part also joined the project recently. And you have the others partners, some representing manufacturing as Onyx, and some representing the application as Acquo, for example, in France for agriPV. Lightyear, in the first version of the project, we had Sono Motors, but they have changed their mind and they leave the consortium. And Lightyear will enter the consortium. We have also Branca looking for a VIPV application, but we will see that. So what are our activities? So we will build several pilot lines in different sites. So we have 6 pilot lines. Some are really industrial pilot lines. Some others are more in R&D labs. For example, in CA, we will hold a pilot line. In Technalia, there will be one also. You can see in the image below, this is the first tool that has been delivered by the project, so Mondragon, and it's installed 2 weeks ago in CA. So this is a new tool for lamination. In fact, it's a new process that we want to study for the lamination. For this tool, we still have a software layer bring by a company which is called Optimal Computing. And this will represent the 2.0 aspect of the manufacturing process. So they will look to each of these pilot lines and bring some tools to optimize the processes. So this is the software part. Yes. So we will work on the workflow for each pilot lines. There will be a different workflow. And we will integrate some metrology to allow us to optimize the processes. And with all this, we have a cost analysis and a life cycle analysis also at the product layer, level. And we will try to analyze the cost, especially for the new lines with new processes, aiming at reducing the cost. So these are our activities. And we have demonstrations also. It was also a request from the call, so several demonstrations. Something like 10 demonstrations. We have, I would say, the biggest part of this demonstration are in the building area. So we have partners in this area. And so you have some examples on the images. Some are real buildings, some are experimental buildings, as the one that you see here. It's a building, experimental building from CA. And we also have integration on infrastructure. For example, there is a noise barrier that will be installed in Spain along the motorway. We have also agriculture. We have 2 demonstrations in this area, one in open field, as you see the image here, and also we will have a greenhouse with a polycarbonate substrate for the modules. And concerning vehicles, there are several applications. So in the beginning, there was an application on passenger car, personal car, built by Sono Motors. And Lightyear, they also have this demonstration possible. So you know maybe the Lightyear 1 car. We will try to put modules, new modules on this car. And we also work on cargo boats and small trucks for the applications. Of course, for all this demonstration, we are looking for the market. And there is quite big studies on this, especially by a Becquerel Institute that is analyzing the markets, the prices on the markets, and how we can put some new products on these markets. So quite a lot of activities, I would say, around the products that we develop. For example, on the market access, there was an analysis of the value chain for the different use cases that I've just mentioned. It's complex, as you said, so we are looking for the standards, the existing standards in the EU and also at a national country level. So there was, I don't remember, not all countries in the EU, but because it's huge, but maybe 6 or 8 countries that we are looking at in more specific ways. And we analyze the risks that are associated to these countries and to these regulations, to these local regulations. And I just showing a report because we have some public report that you can download from the website. And there are some quite intensive review of requirements that we have obtained from the regulations, the local regulations. And we also try to bring training for the professional of the area, of the sector, so building and so on, mainly building, I would say. And we are trying to organize this. This is the SUPSI University in Switzerland that is taking care of that. Yes, because we have a lot of Swiss partners in the project. It's governed by the EU and the Swiss country. That's why we have CSCM, 3S, SUPSI, and so on. And in SUPSI, they are also very active in this platform. So you were just mentioning that you try to build something at the European level, and in SUPSI, they are trying the same. They have the same goal. So maybe we can discuss together about this. And so they have launched this platform to guide solar architecture and urban planning. So there have been some publication. I think there is a manifesto that is available online. And you can also register on this website and to have some insight. And the idea is to bring some weights at the European level of this market for solar PV. And we also try to organize conference. So there is one really next, in fact, organized by ETF Florence in Italy. So it's specific for integrating PV in the built environment. So you can check that on the web and register if you're interested. We have quite a lot of activity from this area, dissemination and so on. And of course, we have a website and we have some newsletters and various things. We also organize an event. I don't see if we. Yes, here. Do you see? No. It's an event that we organized in Brussels some months ago. It was. The goal was to put some people together and to discuss really in presence about the issue that we have in BIPV and the issue of standards and insurance specifically. It was not only a French meeting, so I think these questions are also concerning other people in the EU countries. And that's it for the presentation of the project. Thank you.
To ask you, because in fact I'm an architect, that's why I cannot give you so much technical details. And I wanted to, you have a site where you give recommendations for solar panels in building and urban planning. And I was wanted to know a bit more about urban planning. So exactly what are you doing? Are you speaking with administrations? Are you...
Yes, in fact, actually, it's very specific country by country. So I would say in France, so we have specific actions that are partially covered in the project, for example. And we also have the same kind of thing in 4 countries inside the project. I don't remember the countries now, but probably in Spain, in Italy, and Belgium, I think. So there are more specific actions in these countries where we try to analyze more deeply the possibilities and to influence the regulations when it's possible. Yeah. But it's a long-term activity, you know. Yeah. In fact, for that, we will organize a specific workshop in each of these countries. In France, I think the first one will be in 25 next year, and we'll try to put that in another event as Energaia. So we try to set up this kind of events with 2 targets, industries and policymakers. And we plan 2 events during the project duration for each of these countries.
Please invite me, the French one. And from your analysis of market regulations in various EU countries, so do you see some EU countries which are more pushing or in favor?
I did not get in this kind of details on my side, but yes, we try to analyze for each country what are because it's really different from country to country. Even for AgriPV, it's surprisingly different also. Yeah. And so we try to analyze each of these situations, but it's quite complex.
It's very complex.
The report I show you is, I don't know, tens of pages. It's a big report.
Maybe I should look also in the report and not ask right now. But for the building, at least building market, have you also analyzed the UNESCO regulations? Because, for example, in Prague, the whole city is a UNESCO heritage. So they have quite specific requirements on how the buildings can look, how can be the facade. So it basically impedes any kind of installation like that in the city center of Prague. So have you considered this also, or is it part of the analysis?
You mean the aesthetic part of the modules? Or?
Like just the regulations.
Just the regulation on very... no, I don't think we go in this kind of details, no. Okay. But we try to have wide solutions. For example, we have colored modules inside the project, so we try really to fit with any kind of requirements that can come from specific requests.
Oh, that's interesting.
So color, uniform aspects, this kind of thing. For example, I think in Bexa in Italy, we developed colored modules with a specific tile-looking aspect. Yeah.
Wow, that's very cool.
Typically, I know that for Onyx, this case is more an incentive for me. As soon as a project is complicated and indeed there are regulations that restrict PV, that's where we come and we arrive with new solutions that usually architects love, and they are their first one to push. But then the problems arrive a bit after, you know, and then oh no, and simply to share as well since I deal with France, but also as soon as there is a French-speaking client, Onyx, the headquarters in Spain, they send back to me. So typically, I get a few projects in Switzerland, a few in Monaco as well, and I can say that it's no comparison. Switzerland and Monaco, the project is just, they sign, then they put pressure on us to get it done quickly, on time, but regulations there is not even a question. It's just they are confident with the product and they see it's everywhere, installed. So there is no question. So it's crazy to have a, yes, such a difference. And Monaco is just, I live, 20 kilometers away. And the same project in France, the other side of the border, is like 2 years to complete. So nonsense. But all right. Thank you very much again, Philippe. And we'll move to the last presentation from Victor. He's going to present the Platform Zero project.
The pointer? Well, it's not right now. Okay, good afternoon, and well, I'm Victor Izquierdo, so I come from Spain, the IREC Research Center, and I want to explain about, speaking about this project, okay, that is a little different of the things that is present now. It's mainly focused in try to develop tools for a photovoltaic companies and well, I show you. The question is that the thing is the consortium is 12 European partners. Here involves research centers and different industries, okay, different companies. And I want to explain a little what happens here. Here happens that we have our research centers that working a lot in emergent photovoltaics. For example, there are IREC, there are HSCTV, and we have a lot of experience in characterization in the frame of the research. Okay, we have tools, we have ways to make inspection about the materials in research, but the problem is that how transfer these tools that we are developing from the industry, because final industry needs some type of quality controls evaluations, no? And exist tools, however, it's not the same tools that we develop in the laboratories. And in this context, is created this project. This project tried to identify what is the limitations that currently have some industries in photovoltaics, and try to how adapt the things that we make in the laboratories in our real cases in the industry. Well, and this is the thing that the origin of this ecosystem. No? Is there are 4 research centers. There are 2 research centers focused in develop or adapting technologies for a transfer for industry cases, and after there are a company from metrology that allowed us to adapting the things that we have in the laboratories to this environment. The context of photovoltaics in Europe, you know perfectly. Okay, the idea is to try to make the efficient electrification of the energy, and there are some type. Well, we try to arrive at some type of the production of electricity, and there are the requirements to try to integrate photovoltaics in every place. No, we're speaking a lot about the integrated photovoltaics. No, and in this context, there are the ideas from the project. The project is trying to solve the problems of the emerging technologies or pre-industrial technologies that currently try to move to industry, provide the tools, inspection tools, efficient, that allow to improve the yield production, because these technologies have this problem, have the yield production relatively lower for the presence of the defects during the production. Well, the overall objective of the project is these 6 points. No, is creating all the new generation of sensors that trying to emulate the things that we make in the laboratory in the industry. we develop an artificial intelligence system that allows to processing all this information that providing these sensors and provide a fast actions, no? Give solutions for the try to identify the problem of the productions and try to provide solutions from solve these problems. We need to develop a data management, integrated data management, because now there are different inspection tools but are not interconnected several times. Now we're creating a platform that they are connected everything and allow to correlate the things that we detect in the beginning of the process and manufacturing with the final of the process. We're creating the infrastructure for creating an efficient platform, okay, integrating everything. And the last is try to push the pilot lines that currently participate in the project, try to push for to obtain yield productions, higher yield productions that currently have. No? And the way to do these ones is this is the concept. The concept is integrating different sensing stations in between the different critical steps. Okay, and the stations we try to make a customizable platform that are based in modular way, that we do integrate in sensors or not depending of the requirements. Not everything is necessary, everything, but the idea is to create an universal tool that we easily integrate in inline conditions. No, and all this all this information was acquired simultaneously and processed by artificial intelligence after a training from the specific case, and with this provide information about what happens and try to detect precritical defects, precritical defects. No? And this allows us to actuate directly in the pilot line production before to have defective material. No? And the project is managed or is proposed in 4 stages. Now we are in the phase 2. The first phase is related to the identification of industrial requirements. Okay, it's a fine definition. The second stage is creating all the tools that we need, all the legs, no, that is supported the different the platform. The first phase is integrate everything together and create a real tool, no stop in concepts, and in the final is integrating in 4 pilot lines and evaluating the impact of these tools, and this provide a feedback for improving the platform, no? And additionally provide the feedback for improving the pilot lines productions. And this is the 4 cases that the 4 demonstrators that there are inside of the project on where we installing this platform. The idea was to find different technologies and with different process inside. For this demo alone to demonstrate the universality of the platform that we are developing. Here we involve technologies that are processed by roll-to-roll, technology processed by sheet-to-sheet. We have an additional thing that is a little different, but it's a manufacturing of nano coatings for improving the photovoltaic performance. And additional, we have a different technology. We have fixed and we have a perovskites. This allows to have the possibility to test the technology with different types of materials, process, and requirements. Okay, and demonstrate the universality of the platform that we're creating. Now I show very faster the things that we are achieving at the moment. We are starting the project in the January of 23. We are creating during the first part all the infrastructure for managing the information. This means that we're requiring, we identifying the industrial requirements, we're fabricating reference samples for the share with the partners. We're creating a database with the characterization performance inside of the laboratory, and we are starting to creating of all this knowledge that we have, okay, in terms of with the information about the industrial requirements and the requirements that we need for the characterization in terms to evaluating the different materials in different steps of productions. We are starting to design new concepts or new sensors that allow or achieve information in inline conditions. Okay, here in the inline conditions we are taking some target is monitoring in less of 5 minutes 1 meter square of the material. Okay. And we continue with a second set of the samples for evaluating the sensitivity of the sensors. This is starting in March of this year. Now we're creating a small version of the platform for starting to evaluating the interaction between the sensors and starting to evaluating the automatization of all the things, all the information. Here is a platform that is created now for starting to evaluating all the software or hardware interactions. We're creating infrastructure, management infrastructure that allow to do compatible with the acquisition of different type of the signals, because this is another. We have a characterization with a different techniques, 50 techniques, and this involves techniques of electrical measurements, imaging, and spectroscopic techniques. And these have a different ways to different format of data that after we need to synchronize and try to readapting for after ingest the artificial intelligence algorithm for the training. No? We are starting to test the first generation of artificial intelligence that we introduce all this information, and he provide prediction about the process is correct or not correct. Okay. And now we are working in, this is the state that we have currently, is the multiplexing the sensors. Try to integrate everything as minimum possible in modular way in order to do efficient integration. It's not possible to integrating several techniques in one another close to the other with a serial, because this is not efficient way. Here the idea is to integrate everything as maximum techniques in the same point for evaluating in the same point simultaneously several parameters of the material that has deposited. Now we are working in the second generation of artificial intelligence, now with the things that we identify, what is relevant or what is not relevant in terms of the data processing and data preparation of the information. Now we are creating this new. We are starting to create the architecture for a modular way to integrate all the sensors inside and to do it compatible with roll-to-roll production and sheet-to-sheet production. And we are working in all the software for managing everything, because here is a big challenge how manage all the interaction between the different elements that are inside of this platform. And it's expected that during the next year we start into the implementation of the real systems for the integration in the pilot lines, and during the 26 we're making the validation in a real conditions production. Well, the project outcomes, well, more or less I say that the idea is to increase the sustainability of photovoltaics to reducing the fails during the production. We provide, the idea is to detect the deviations in critical conditions, okay, that we see that the parameters from the deposition of the layers or the processing of the materials is starting to go outside from the expected parameters. We creating a diagnostic methodologies, a new inspection methodologies compatible with inline, things that now we make only in laboratory. The idea is to transfer directly to the industry and increase the use of materials that this allow to reduce the price of the production cost. We expect to impact in a 10% increase in the productivity of the pilot lines that are involved in the demonstration, and decrease the 10% of the materials, no? That mainly focus in high value raw materials like to indium, for example. Well, additionally, after the project, there involves a lot of technological developments, and the idea is to creating different key exploitable results that mainly make sensors that after can be used for other technologies, not only for photovoltaics, for materials in general industry. Develop strategies for integrate these things in sheet-to-sheet and roll-to-roll, because this is a challenge, how makes compatible with this. We implement an artificial intelligence data library, algorithms library for after to apply for another type of applications. Implement this the same for the management and control. The idea is to creating all the things that we have, maybe it's not stop in the photovoltaics, move to semiconductor companies and materials processing industry. Implement a full operative platform that we started evaluating in photovoltaics, but the idea is to try to transfer after another type of the sectors, industrial sectors. And finally is make efficient the detection of the process in early stages, no? and improving the photovoltaic production. And well, I add these ones because we know, and it's a thing. We're creating a tool, and a tool that our idea is try to do as maximum general possible. Here there are is presented several projects, and that the link is the photovoltaics, and I think that there are several things that we are developing that could be compatible with your technologies. Okay, not in the way maybe that we present, because obviously there are cases, there are different things, but we are a possibility to try to implement the things for organics. For example, organics is not inside of our knowledge. We're never testing these technologies in organics. In silicon, it's very complicated to implement new things because it's closed. it's a closed sector, and for example, we think that we have tools that could be help to the photovoltaics, the silicon technology improving and detect the deviations in early stage. For example, the detection of different batches of silicon wafers. We have a preliminary testing that we detect variations between the difference. In theory, similar wafers is not as similar. There are some small variations in the polishing of the surface, the type of things. And move another technologies like tandems. And tandems is something that now looks that is pushing a lot. We need to go a very high efficiency. And here we are only develop technologies for evaluating normal photovoltaics structure, but for us it was nice to try to evaluate on these new generation things. Well, thank you very much. And here you have the QR if you want to enter in the webpage of the Platform Zero. And we are very open to collaborations and try to find ways to create synergies. Okay. Thank you very much.
Martina, yeah, you're first.
Sorry, I already have a question because I previously worked on another project which was focusing, it was again with TNO. TNO is coordinating Super Tandem as well, but there TNO was the use case partner, and it was about the inline monitoring of the sheet-to-sheet process for perovskites. And we were using hyperspectral imaging to see, let's say, the formations of the crystals and all of that. And it was really interesting. It finished last year or the year before, I don't know. But in the end, it was very difficult to work with this amount of data because the hyperspectral cube was huge. And in the end, they didn't keep the camera at TNO. It was interesting to see how, to see the results. But I think it's quite, like you mentioned, it could be interesting to see with the line that you're developing and the sensors to see how it would work on the perovskites.
We have inside of the consortium there are Saule, and I know this problem about the crystallization of this one. And the idea is this one: how manage all this information. This is the main thing. We created several sensors. The idea is to training with a standard process and detect when the picture that you obtain. But picture is a strange concept, no? Because it's not a continuous picture. It's a picture that you obtain in the first step, second step. You mix everything. And with this, we detect deviations of this case. For example, in this case, maybe here we are detected that maybe we don't understand what happens. I cannot provide you need to change the temperature of these ones, but we detect these ones very, very faster, very sensitive. And the combining several things allow to discarding the presence of the different things. And for us, it was very interesting to try to explore this type of things, and use the artificial intelligence in these ways is the only solution that we have. No, it's because it's impossible to manage all this information.
Yeah, I guess now you will have an advantage because the artificial intelligence has advanced so much that you will be probably able to do what we weren't able to do in. I can show you the project afterwards. It was called NanoQI, and we arrived at the end of the project and we had large amount of data that we could not
For us,
analyze.
it was very interesting to.
And it was a nightmare. so yeah, maybe we can talk after.
Okay, thank you.
Any feedback from the other projects, collaboration?
In fact, so we work with optimal computing. I don't know if you know this company. Optimal computing.
No, I don't work with.
I think they already have a platform which is called Visualia.
Mm-hmm.
And so this tool, I would say it's not completely developed for our purpose, but one of the goals is to practice data fusion,
Mm-hmm.
including image analysis,
Mm-hmm.
and other kind of measurements that we can have. For example, in our case, for the pilot plan we will have in CA, we hope to be able to include the analysis of electroluminescence images, for example, and maybe fuse these images with other data like IV curve or these kind of things. So it's a real concern for us. I don't know if we can compare the techniques maybe in more details to check what are the capabilities and.
Now, for example, now we integrate this as something that I didn't explain with data. It's about we integrating a very different technologies, the inspection techniques. We are moving from the visual, for example, electroluminescence, imaging electroluminescence, and visual detection of crystals and this one. We are inside, but we have another spectroscopic, for example, that is you don't have imaging. You have here we have a lot of problems about how merge all this information, because finally you need to creating a coherent database with all the information that you have. And we are creating strategies to try to combine how transfer the point-to-point measurements to imaging and how transfer the imaging to point-to-point. And with me, make a data fusion for making efficient the artificial intelligence. This is a huge challenge, and now we are some results that goes that this is possible to do, and we have some strategies. Obviously, this is a thing that now we're working well for the 4 cases that we are evaluating. For us, it was very interesting to try to transfer to another technology and see what is the requirements, because sometimes the problem is only the communications, the communication between the researchers with the industry. Things that we can do in research is not compatible with industry. However, readapting a little is possible to obtain some things. Okay,
maybe a question concerning the kind of defects that you are able to detect.
Mm-hmm.
Because, for example, when we develop new processes,
Mm-hmm.
sometimes we have new defects that were not expected. So it could be interesting to see the range of defects that you can see and analyze.
The strategy of the project. The project don't detect not detect which is the deviations. Detect which is not the same of the things that you want to obtain. This is another way to make front on the problem. We creating, this is the way that work in our platform, is you create first a training with your standard production. Okay, this is my standard production. All the things that is outside of these ones is not a standard. Okay, this is the first approach that we make. For example, now you change the process and you obtain a new defect. Okay, this is not a problem. The system that we're creating detect this one, detect that there are something that deviation. After this is good or not is another thing, because sometimes you have a deviation that is positive. However, for the point of view of production, you want to keep the standard, no? And this is the concept of the tool, creating the way that without know everything, detect which is not the same that you obtained yesterday. And this is very, very, very suitable for standardization things. And there are another. Here is focusing in industry. However, we are working and we apply these things in research. We are currently now, the platform that we show previously, these small things, and this now is a tool that we are using for development of new process of new things, because you have the tool to now detect what is not expected, and after you focus in this for understanding what happens. You selected the samples or the things that you considered that are relevant, the things the system tells you have a problem. In photoluminescence, for example, in electroluminescence problem, you select this sample, and after With this, you stop and make a real research analysis. And this allows to the researchers from the new materials to increase very faster, no? Because sometimes you generate material, but you detect variations, but you don't know what happened. In this case, it's not necessary to evaluate everything, just only selecting the relevant samples that you want to analyze. Okay.
Thank you very much, Victor. I think we had a very good discussion in this workshop, although it was a small audience. Really interesting, and probably many things to discuss, I guess, after the workshop itself. So thank you very much again to all the speakers. I guess we will keep in touch and see you later at the dinner.